Hey there, in this video we're going to cover exponential functions. So an exponential function with the base a is defined for all real numbers x by this function notation, f of x equals a to the x, where a is a positive number and a is not equal to 1, right? If a is 1, you just get f of x equals 1 to the x, which is 1. So it's just a constant. So it's the linear function really, y equals 1, the horizontal line. So that's why we say a not equal to 1. As soon as we change it from 1 though, so say I have, for example, f of x equals 2 to the x. Now that's a different function. And let's evaluate it. So say I want to find some values. Let's find f of 0, f of negative 2, and f of 3. So with any function, right, we replace the x with the number inside the parentheses. So that means that f of 0 would be 2 to the 0. And we use our properties of exponents that say anything to the 0 power is 1. Well, any non-zero number to the 0 power is 1. So f of 0 is 1. F of negative 2, again, we replace the x with the negative 2. So I'm going to have 2 to the negative 2. And properties of exponents tell me whenever I have a negative number in the exponent, that means 1 over 2, and the exponent becomes positive, so 2 squared, so this becomes 1/4. If f of 3, replace the x with the 3, so it becomes 2 cubed, which is 2 times 2 times 2, which is 8. So as coordinate pairs, this will give me x is 0, y is 1. This is as xy. Here x was negative 2, y became 1/4, and for this one we have x is 3 and y would be positive 8. Let's try another example. What if I say g of x, so for another function, g of x equals 3 to the x minus 1. And same thing, let's find some values. So let's find g of 0, g of negative 1, and g of 2. And same thing, we replace the x with the value in here. So I'm going to have 3 to the 0 minus 1, which is 3 to the minus 1. So it becomes 1/3. G of negative 1, so that'll be 3 minus 1 minus 1. So that's 3 to the minus 2. So similar as we did here, 2 to the minus 2, the negative really means it belongs in the denominator. So I get 1 over 3 squared, which is 1/9. And g of 2 becomes 3 to the 2 minus 1, so it's 3 to the 1, which is just 3. So again, as coordinate pairs, in terms of x, y, this will be x was 0, y became 1/3. When we evaluated when x was negative 1, y was 1/9. And when we evaluated when x was 2, y became 3. And so this is how we evaluate exponential functions. So the next thing I want to do is, what does the graph of an exponential function look like? We've been graphing polynomials and we've been graphing rational functions. So now let's look at exponentials. So say we want to graph f of x, the first one we did, graph f of x equals 2 to the x. And when we don't know what a function looks like, we're going to resort to using a table of values. So I have x, and remember f of x is just a fancy name for y, so y equals 2 to the x. And I usually do some negative values, so negative 2, negative 1, 0, 1, and 2. Let's think about the domain. Can I plug in negative numbers in there? Yes. As the domain is anything that makes the function undefined, or the x values that make a function undefined. 2, any exponent that I put on 2, I'm going to be able to evaluate it. So we should be okay. So let's try it. So negative 2, when x is minus 2, I'm going to have 2 to the minus 2, which means 1/4. We did that one above. And when x is minus 1, 2 to the minus 1, this is 1/2, 1 over 2. 2 to the 0, any non-zero number to the 0 power is 1. and 2 to the 1 is 2, and 2 to the 2, that's 2 times 2, which is 4. And so when we go plot these values on my x, y axis, let's see, a negative 2, so negative 2 is over here, negative 1, 1, 2, negative 1, negative 2, although notice that we're not getting any negative values, so I don't really need those, 1, 2, 3, 4. So let's see, when we're at negative 2, looks like it's 1/4. So it's going to be, here's positive 1, so divided into 4s. So it's going to be somewhere way down there. When x is negative 1, we get 1/2. So half of that at 0, we get 1. And at 1, we get 2. So notice that now it starts to increase really fast. So this is the graph of an exponential. Pretend that that's a really nice graph. So here we have our graph. So this is the point 2, 4. This is the point 1, 2. And our y-intercept is 0, 1. And then we have the negative ones. So I'm going to just label this one -2 and 4. So there is the graph of our exponential. So this is the graph of y equals 2 to the x. Now if I wanted to graph 3 to the x, and say I want to do it in the same axis, so I'm going to go over here. If I wanted to graph 3 to the x, we do the same thing that we did with the other one. So I'm going to have -2, -1, 0, 1, and 2. And my values here, because it's 3 to the x, I'm going to have 3 to the -2, which is 1/9, 3 to the -1, which is 1/3, 3 to the 0, and a non-zero number to the 0 power is 1, 3 to the 1, which is 3, and 3 squared, which is 9. So if I plot these on the same axis, notice that when x is -2, I'm going to have 1/9. So this was 1/4. Which one is smaller, 1/4 or 1/9? 1/9, right? The bigger the denominator, the smaller the fractions are going to be below. At -1 is 1/3, so it's going to be below 1/2. But notice that at 0 we touch the same y-intercept. But then when x is 1, we go to 3. So we increase over here to 3. And when x is 2, we go all the way to 9. So somewhere over here. And so when it's for negative numbers, we're going to be below 2 to the x. And when for the positive numbers, we're going to start increasing really fast. So this will be the graph of our exponential 3 to the x. So this will be y equals 3 to the x. And so notice that as the base of the exponential, with these, the 2 and the 3 are the bases. So that's the base of the exponential. As the base gets larger, our exponential is going to grow faster. Imagine if this was 5 to the x, right? 5 to the x when x is 1 will be 5 to the 1, which is 5. When x is 2, you're going to have 5 squared, which will be 25. So that's going to grow even faster. When x is positive and when x is negative, it's going to get even slower here. Very, very small, right? -2, 5 to the x will be 5 to the -2, which will be 1/25. So that's how exponentials work. Exponentials are characterized by a horizontal asymptote. You can see that 0 is a horizontal asymptote. So it gets really, really, really close to 0, but it never reaches 0. And another way you can think of that is, can you take this function 2 to the x? Is there any power that you can put in here that's going to get you 0? And it's not possible, right? There's nothing you can raise 2 to get 0. So this is not possible, so that means we're never going to touch the horizontal asymptote.